The magnetic compass is yet another crucial instrument, whether you're flying in clear skies or through clouds. It's pretty straightforward to use, but sometimes it can throw you a curveball with its errors. So, let's first review the compass markings. We'll figure out why it's marked the way it is, which will make it easier to wrap your head around stuff like variation and the difference between true course and magnetic course. The compass card has 4 letters representing the cardinal directions. The numbers show angles in increments of 30 degrees, with the last 0 dropped. Long lines mark 10-degree intervals, while short lines mark 5-degree intervals. These angles are measured from magnetic north, so due north is at 0, or 360 degrees, representing a full circle. Notice, if the angles are measured clockwise, they are positive and increase from 0 all the way to 360. However, if we measure angles counterclockwise, the opposite direction of the clock's needle rotation, the angles are negative. And you'll see the numbers decreasing from 360 back to 0. Remember this, as it will help in understanding how variations are labeled. You're aware that the Earth's magnetic North Pole doesn't coincide the geographic North Pole, right? In aviation, we call the angular difference between the two poles variation, also commonly known as declination. This variation changes depending on your location's latitude and longitude. Different places can have different variations. Connecting places with the same magnetic variations, we have isogonic lines. Along these lines, the variation remains constant, making it easier to convert between magnetic and true courses when flying across large areas. The isogonic line with a variation of 0 degrees is called the agonic line. Along this line, the magnetic poles align with the geographic poles. Flying along the agonic line, your magnetic compass points to true direction. Your magnetic and true courses converge. To the west of the agonic line, you'll see isogonic lines marked with positive degrees, labeled with an E on sectional charts to indicate east. Conversely, to the east of the agonic line, the numbers are negative. On sectional charts, they are designated with a W to signify west. Let's uncover the reasoning behind this labeling. On the east side, variations are labeled as west because the magnetic North Pole sits to the west of the geographic North Pole. You see, suffix letter W tells you that the magnetic North Pole is positioned to the west of the geographic pole. Similarly, on the west side, the magnetic pole lies to the east of the geographic North Pole, hence it is postfixed with the letter E. Now, you know why it's called magnetic variation. It's because the position of the magnetic poles varies in relation to the geographic poles. Makes sense, doesn't it? Furthermore, when the magnetic North Pole is to the east of the true North Pole, the angles are formed clockwise, so the variations are positive. When the magnetic pole is to the west of the geographic North Pole, the angles are formed counterclockwise, and labeled as negative. Let's see how to determine the magnetic course with 2 examples. Imagine 2 airplanes both flying a true course of 30 degrees, one in an area with a variation of 10 degrees east and the other with 10 degrees west. We can visually determine the magnetic course using 2 compass roses, one pointing to true north and the other to magnetic north. With a variation of 10 degrees west, the magnetic north is 10 degrees to the west of the geographic North Pole. So, a true course of 30 degrees equals a magnetic course of 40 degrees. On the other hand, with a variation of 10 degrees east, the magnetic north is 10 degrees to the east of true north, resulting in a magnetic course of 20 degrees. Alternatively, you can crunch the numbers. Magnetic course equals true course minus variation. For 10 degrees east, we have 30 minus 10 equals 20, just as we discovered graphically. But for 10 degrees west, remember the numbers are negative. 30 minus negative 10 becomes 30 plus 10, which equals 40. Ta-da! Matches our graphical method yet again. You'll spot this same equation on the backside of your E6b. And guess what? You can flip the equation around to compute the true course from the magnetic course. Don't mix up the magnetic course with the compass course, they're not always identical due to compass deviations. Here's the scoop: the electrical equipment on the aircraft creates its own magnetic field due to the flow of electric current. And the compass magnet wants to align with any magnetic field it encounters, even the tiny ones from the aircraft's equipment. So, sometimes it might veer off from the Earth's magnetic field, leading the compass astray from magnetic directions. A compass correction card typically accompanies the compass. The 4 rows indicate the magnetic course you're aiming for, while the steer rows show where your compass actually wants to go. The difference between them is your deviation error. Let's say you want to head due east magnetically, your compass course should be 095. Sometimes, you might come across a compass error card that looks like this one. Don't fret. You can apply the same method used to calculate the magnetic course from the true course. If your magnetic course isn't listed, you'll need to interpolate the corrections. For example, if your magnetic course is 220, plug the numbers. Your compass course would be 221. Keep in mind that deviation errors are aircraft-specific and vary with heading. They can also change after a visit from a certified aviation maintenance technician. So, always double-check before takeoff. Alright, that's enough number crunching. Let's call the day and focus on the dip errors in the next video. Stay tuned.